Now we're going to talk about inductive effects. And in the packet that you all have, the definition of induction is on there. Induction is the pull of electron density through sigma bonds caused by electronegativity differences between atoms. And that pull allows for more electron delocalization. Essentially, with acid-base chemistry and trying to understand which conjugate bases are more or less stable, more delocalization of charge almost always equals more stability. And again, if a conjugate base is more stable, that means that conjugate base came from an acid that was a stronger acid. So what are inductive effects? So let's work through a couple examples here. So we're going to look at the molecule ethanol versus trifluoroethanol. And in trifluoroethanol, we have our fluorine atoms on the terminal carbon position. And if either of these react with a base, so again, we'll put in B-, they are going to be deprotonated to the alkoxide. The alkoxide just means the O- species. So over here, we're going to have BH plus ethoxide. And over here, with the one with trifluoroethanol, we're going to have BH plus trifluoroethoxide. So CF3 ethoxide. So if we're trying to understand is ethanol or trifluoroethanol more acidic, we have to try and understand which of these conjugate bases is more stable. And essentially what we're looking at is which of these has more charge delocalization, because if you have more charge delocalization, you're more stable. And what induction is, again, is the pull of electron density through sigma bonds caused by electronegativity differences between atoms. So where do we have electronegativity atom differences? So CH3, there's no electronegativity differences. CH2, nothing. CH2, CF3, that's different. So fluorine is the most electronegative atom. If we look at our abbreviated periodic table again, fluorine is way over here. It's the most electronegative atom. So that is going to pull. So if we draw this again here, and we'll draw out the fluorine atoms, the fluorines themselves are going to be pulling electron density away from the attached carbon atom. So this is going to be pulling electron density, causing it to be partially negative. So all of the fluorine atoms are doing that. And because all of them are pulling away from the same carbon atom, that causes it to be partially positive. And it turns out that when one carbon is partially positive, it transmits that partial positive down the carbon chain. So there's also a partial positive on the next position. Because of that, the negative charge here that is on this oxygen, so it's the same negative charge here versus here, but this one is next to a partially positive position, and that allows it to delocalize charge onto that position, stabilizing the structure. So this induction allows for the electron delocalization. So if we, because of the induction, this negative charge seems to be less focused on that one atom and more spread out through the molecule. And you can see this with computational data. So if we look at ethanol, the computational data, and you do a electrostatic potential map, it spits out a structure that makes the most negative part of the molecule red, and that's what you see here. So this is ethanol. The oxygen atom is right here, and it's very negatively charged. Trifluoroethanol instead, because of those fluorine atoms that are pulling electron density away from the carbon atoms, you can see that the color around that oxygen is more yellow. It's less intense because that oxygen is able to delocalize its charge onto the carbon atoms next door. So this conjugate base is more stable because of induction. So if that conjugate base is more stable, then this acid is more acidic. So that is the inductive effect. And so how does that manifest itself in pKa value? So ethanol, we had to learn that pKa value in that pKa chart. Ethanol's pKa value is 16. It turns out trifluoroethanol has a pKa of 12.4. So we lost multiple pKa units because of that induction that stabilizes the negative charge of the conjugate base. So that is how induction works.